Okay, this problem, we only had one of these today. You are doing an acid-base reaction. So I've got a quantity of sodium hydroxide and a quantity of HCl, and I'm going to react them together. So I'm going to put HCl here. Remember, you take an acid, strong acid, and a strong base, and we're going to get salt plus water. Okay. Now, I've got 10 milliliters of a 1 molar solution in each case. So 10 milliliters of a 1 molar solution. So again, they're making it easy for you. Ooh, sorry about that. And what we're going to do is, again, I'm going to do this with scientific notation. You can move your decimal point. You can do this however you want. But I'm just going to show you again that if I tuck all my zeros away, I'm not going to lose them. So I'm going to get 1 times 10 to the 1 divided by 1 times 10 to the 3 times 1. Remember, 1 divided by 1, you divide the coefficients is 1, and you subtract exponents. 1 minus 3 times 10 to the minus 2. And you can keep it this way through the whole problem. I'm going to convert it to 0.01, but I don't have to. I can use this. This is the number of moles I have, and I never have to worry about that. But let's go ahead. I'm going to make it be 0.01. Okay, so now let's do the delta H part. We're going to do delta H of reaction is equal to a negative Q divided by moles reaction. All right. Now, moles of reaction, I'm going to get up here. Everything here is 0.01. So all of my stoichiometry of 1, where I have a 1 in front, is 0.01. So let's plug all this in. What I'm going to have to do is I'm going to have to calculate Q. So this is equal to what? So remember that Q is equal to MCAT, mass, times specific heat, times change in temperature. And that's in your formula chart. So this equation is in the very top part of your thermodynamic section of your formula chart. But what they did is they kind of helped a little bit with the quantities. Now the mass I'm going to use, remember when I use solutions and I combine the solutions in one calorimeter, I add the volumes of these solutions and assume a density of 1. So 10 and 10 means I have a negative and then 20 grams. I'm going to use 4.2 as my CP, and then my temperature difference, remember I'm going, the final is 26, final is first, so that's 26 minus 20. Remember, you have to worry about that because this number right here is what's going to determine the sign of your enthalpy value. So you don't want to get those mixed up. Final is first, so whatever you're going to, 26 minus 20, all right? And then I'm going to divide that by moles of reaction, which is 0.01. Now, when you're doing this, you can kind of estimate, right? And that's kind of what I'm going to do. I'm going to say, okay, I have 20 times 4.2 is 80 times 6, but it's a little higher, would be about 480. But as you can see here, I'm probably around 500. So I'm going to call this 500. And that is divided by 0.01. Let's put this into scientific notation. So I'm going to say a negative 5 times 10 to the minus 2 divided by 1 times 10 to the second divided by 1 times 10 to the minus 2. That is going to give me 5 times 10 to the fourth joules per mole reaction. Remember that the reason that I'm in joules and not kilojoules is because my specific heat here is in joules. So I'm just going to divide this by 1,000, and I'm going to get 50 kilojoules per mole reaction. And my sign, of course, carry that through, is a negative, and so the answer is A.